button. All the pressure got to me. There we go. All right, well, thank you to everyone for attending our invasive forest pest webinar series in collaboration with the Entomological Society of America. This is the first of the 4 different webinars that Giovanna outlined in the introduction, and it is in support of 2 different multi-entity partnerships that both will benefit from the perspectives and conversations that we're going to be having today, tomorrow, and next week. And those 2 partnerships are the Nature Conservancy's Continental Dialogue on Non-Native Forest Insects and Diseases, as well as the Entomological Society of America's Grand Challenges Agenda for Entomology program. And so together, we created this webinar series in order to highlight some key partnerships that help. Sorry, it's a great time to get a phone call across the house. That will help us all work together in order to advance forest pest partnerships. And if that wasn't the best introduction you've ever seen, I'm not sure what will be. So today, our webinar leaders will be me, Lee Greenwood. I am the Forest Health Program Director of the Nature Conservancy, and Erin Cadwallader, the Director of Strategic Initiatives for the Entomological Society of America. So I'm going to start out with telling you all a little bit about myself, and then I'll hand it over to Erin in a moment here. I have worked for the Nature Conservancy for over 10 years now in the capacity of forest health. I started with the Nature Conservancy in the realm of firewood, and I have expanded my role through time to incorporate the entire spectrum of forest health issues in North America from the Nature Conservancy's perspective. And I'll be getting into that during my strategic planning conversation that we'll be having as my formal presentation in a few minutes. I've been engaged with the Continental Dialogue, which is the program that we'll be talking about in terms of partnerships, since the beginning of my time with the Nature Conservancy, but it actually does predate the work that I've done. So I would like to take a moment to let Erin introduce herself as well.
Thank you very much, Lee, and thank you so much for helping organize this. I think we're going to have a series of some really great conversations, and I know Lee and I are both looking forward to the input from the audience, all of you guys in attendance, to hear your thoughts and perspectives as well. To provide a little bit of background on myself, as Lee mentioned, I am the Director of Strategic Initiatives with ESA. I started in this role in January of 2020, so most of my time working in-house for ESA has been remote during the pandemic. And thus my view has not changed much. But for the prior 4 years, I have played your lobbyist on Capitol Hill. So in my last job at Lewis Burke Associates, which is a lobbying and consulting firm that represents universities and scientific societies and other large research infrastructure entities, I started working with ESA in 2016 and fell in love with all the different topics on which I advocate for the society. I am a scientist by training, but my background is in developmental biology, and I worked with zebrafish, so not a lot of overlap with forest health. But if you're ever interested in hearing about my dissertation that involved exploding embryos, I think maybe entomologists are the only people that might be able to create a similar model system to generate those kind of outcomes. So to provide a quick background on the Grand Challenges program, which I'll talk more about tomorrow. The Grand Challenges was created in 2014 as a goal of really identifying the spaces where human suffering can be alleviated by the expertise and knowledge of entomology. And a large group of individuals came together and really whittled this down to 4 priority areas. Those are sustainable agriculture, vector-borne diseases, invasive species, and biodiversity loss. And biodiversity loss is our most recent addition to this group. The goal had been to really bring together other entomological societies from around the world to try to explore ways that we can support each other's work and collaborate and coordinate to address these challenges. That's been a work in progress since 2014. And as I'm sure you can appreciate, those kind of alliances don't come together overnight. But we had a lot of success bringing together collaborators in 2016 around the Zika crisis. And in 2018, we held a summit in conjunction with the ESA annual meeting, along with the Canadian Society for Entomology, focused on invasive species. And so that's really where our involvement today comes from. The 2018 summit had a goal of identifying some really discrete ways that the entomological community could help address invasive species. And as it turns out, it's a much more challenging topic than I think any of us had appreciated when we all came together. And so even identifying consensus opportunities to work on was a bit more challenging than expected. One of the best outcomes of this was that it created a new relationship for us with the National Wooden Pallet and Container Association. And so we've really started looking more closely at ISPM 15 and opportunities around data and compliance and enforcement and education. And that's what led to the gist of this conversation as well. We had hoped to have, of course, meet together in 2020, then the pandemic ruined that. The same thing, we decided this year not to try to host something in person in conjunction with our annual meeting, given constraints around travel and unvaccinated children and a lot of other challenges that made the idea of sitting around conference tables trying to hash out some of these issues just unlikely. So instead, we've been discussing a different way forward that I'll talk more about tomorrow, and I'm offering that as a teaser. So with that, I'm going to turn it back to Lee, and thank you all, and look forward to our speakers' presentations today.
Thanks, Erin. That was great. So as a note in terms of the procedures of the webinar, we have this in the webinar format, which means you can't see each other aside from the panelists. And if you do need to if you would like to speak up using your microphone, you have to reach out to Laurel Downs, who is the Forest Health Conservation Coordinator for the Nature Conservancy. She is online, and in the chat, you should be able to just reach out to her and say, please take me off mute, I have a question or whatever. And additionally, as we get going, if you have questions, you can either put them into the chat or the question and answer box. It doesn't actually make a big difference in terms of the administration of the meeting itself. We will be able to take a lot of question and answer because we intentionally really made sure that this webinar series has a lot of time in between each presentation, as well as at the end built in for a conversational approach. Additionally, the tech side of this approach is being handled by Giovanna, who did the introduction earlier. So if you do have some sort of technology type issue or other Zoom-based emergency, you can try to reach out to her and see if she can help you out via the chat box as well. So let's see. So for today, what we're going to be talking about is the invasive forest pest continuum where it starts, which is before it reaches the border of the place where an invasive pest becomes invasive. And that's an incredibly important space because, as I think everybody who would join this webinar can appreciate, prevention is obviously an incredibly powerful tool in the invasive species space. The nature of an invasive species is such that by the time they arrive, their aggressiveness in an invaded habitat makes them difficult to control. That is invasiveness at its finest. And so the before the border space, the prevention even before it reaches a potential new range is one of the most important elements. So the three speakers today are going to be, first of all, myself. I'm going to give a presentation on the Continental Dialogue, what it is, and how we are currently engaged in the strategic planning process. And then we will have two more presentations that are themed on before the border. And those two will be Yuri Holzer with International Cooperation and Risk Analysis with the University of Florida, followed by Dr. Angela Meck, who is giving a presentation on the High Impact Insect Invasion Working Group, which is a multidisciplinary working group that has a lot to offer to the invasive species space. After 3:40 or thereabouts, when Angela finishes up, we'll have opportunity for a discussion up until as late as 5 o'clock Eastern, but we actually don't really anticipate, unless things get extremely heated, taking up that entire space. We just wanted to make sure that the discussion had plenty of time for whatever topics come up. And I just want to take a moment to remind you all, write down in your notebook If you're interested in this series, there is another one tomorrow as well as next week, and you need to sign up for each one separately. This Zoom link won't work for the one tomorrow. So with that, I'm going to take a deep breath, and then I'm going to put on my presenter hat as opposed to my introducer hat. And we can all meditate on this beautiful fall winter scene in Montana, which is where I am coming to you live from on this Zoom presentation. I also wanted to let everybody know, because I always find it very disconcerting in this format of Zoom. We had over 75 people register for this webinar. So while I actually cannot see precisely how many people are on right now, I assure you that we have a substantial audience, which I'm excited about. So thank you all for joining. All right. So I'm going to talk today about what the Continental Dialogue strategic planning process is looking like. And for me to talk about that, first, I have to describe to you, why is the Nature Conservancy doing any of this work in the first place? And then also, what exactly is the Continental Dialogue? So first we have to figure out who we are, and then describe the secondary group, the dialogue itself. So first off, why does the Nature Conservancy have staff and work, advocacy, and research in the forest pest realm? The biggest and most straightforward explanation for this is that the two key tenets of the Nature Conservancy right now, which we self-describe as the dual threats of the climate crisis and a loss of biodiversity, are both profoundly impacted by forest pests globally, as well as particularly in North America. So when we say that these are the primary goals of the Nature Conservancy, we know that forest pests touch down very significantly in both of those spaces. In fact, I was one of the co-authors on a recent paper that was just published a couple months ago in Frontiers, and it was specifically quantifying at a very gross level across the contiguous United States, what sorts of impacts do we see from insects and disease disturbances in carbon sequestration. Because as we all know, if we're going to get a grip on the climate crisis across the globe, we're going to have to take a multi-pronged approach. Not only will we need to reduce emissions, but we will also need to ensure that carbon sequestration is maximized by all the natural services that forests, as well as other ecosystems, of course, have to offer. And without getting into the finer details of this paper, I'll give you just a very top line highlight. We found that highly impacted landscapes are having a tremendous loss of carbon sequestration potential from both native and non-native forest pests. And because this presentation today that I'm giving right now is about non-native insects and diseases, it's important to note that this paper, if you look it up, is about both. But the areas, the geographies and the ecosystems that we researched in this paper to outline the potential points of action and the disturbances that we were looking at included extensive areas with non-native forest insects and disease disturbances as well. So we're talking about things like a 69% reduction in carbon sequestration potential in some of the most disturbed forests that we researched. So it's a really huge carbon sequestration impact from forest pests. But I think that that is only one tiny piece of the puzzle. We also know that forest pests have huge impacts on the other values that the Nature Conservancy works to protect across the globe. Biodiversity being top, but also things like clean water, the livability of our cities and our built environments, the quality of life throughout the world depends on healthy forests and trees. And so invasive species touch down on the Nature Conservancy's core values in just about every space, and especially within forest pests. So that's why the Nature Conservancy is giving this webinar in the first place, or participating in this webinar in the first place, and engaging in the forest pest areas. So the next question becomes, well, you know, as a global organization, where do you draw the line? Where is the full scope of the forest pest space for the Nature Conservancy and for the Continental Dialogue? And that gets into the very beginning of the strategic planning process, because in order to create a strategic plan, you have to scope all the things you could do and then pick the things that you're going to do at its most basic. And so we've been engaged in that scoping process. In order to do that scoping process, we had to take a step back and look at what the mission of the Continental Dialogue is. The Continental Dialogue is this multi-stakeholder sort of loose affiliation and meeting and partnership entity, does not have a membership structure, that has the mission to cultivate and catalyze collaborative action among diverse interests, like I said, very multi-stakeholder, to abate the threat to North American forests from non-native insects and diseases. Now, that definition of North America does in fact include both Mexico and Canada. So through the inception of the Continental Dialogue in 2005, we have engaged with both private and governmental entities throughout our 2 neighboring countries, beyond just in the United States itself. I had actually hoped to get some Canadian representation into this webinar series because we have been doing quite a bit of work with them, but unfortunately we accidentally cross-scheduled today and tomorrow with the Canadian Forest Pest Forum, which was an unpleasant mistake because we really were hoping for them to be able to participate. So hopefully we'll be able to get them into our next webinar series. And of course, at the Entomological Society of America's 2022 meeting will be in Vancouver. So we will certainly be able to meet up with the Canadians at that time. So when we look at the mission, it's clear that we have to consider how to abate the threats, and those threats do not originate typically within the North American continent. Typically, they originate off continent, overseas. And so you have to go to the full prevention, the before the border aspect in order to address them. And in fact, in order to create a full scope of what the Continental Dialogue might look at from a strategic planning process, we created a conceptual framework to help us understand it. This is not the only way to look into the forest pest threat. It is the way that we chose to divide up the world so that each sort of bite could be more manageable to abate the threat to North American trees. And the 5 different spaces in the scope that we defined are prevention, early detection and arrival, which we'll be talking about extensively tomorrow at that webinar. The initial establishment phase, so early establishment of an invasive species. The management phases in terms of the early and ongoing, and this is domestic management that is active on either the forest pests themselves or the host trees, depending on the context of the system that you're managing. And then management of, I have the wrong word here, I believe. That's my mistake, I'm sorry. Management of the pests when they become naturalized. That's a typo on my part. So when a forest pest has become a naturalized part of the North American forest system, it can be extremely damaging. And the tactics necessary to, for instance, protect host trees from extinction can be completely different than the tactics that we were exploring in the conceptual framework from points 1 through 4. And so in that naturalized system, you're looking at host tree breeding, biological control agent deployment, things like that. So it's a really different paradigm in terms of the continuum, but it's an incredibly crucial one when the other steps have led you to the end of the continuum and you have to deal with sort of the hand that you've been dealt by the forest pests. So those are the 5 different places that the Continental Dialogue strategic planning process has been looking at in terms of where we could engage were we to choose to. But of course, the whole nature of strategic planning is building a strategy of not everything, but the things that you are most capable of or most able to, or have the greatest importance in the overall picture. So that begs the question, well, how are we figuring out where attention and action is actually needed right now within forest pests? And the short answer of that is webinars like this. So we're trying to get a tremendous amount of input from the communities of forest pests, from the private entities and industries that we work with and their representatives. Those include things like the National Wood Pallet and Container Association that Erin mentioned, as well as the AmeriHort, which is the American Horticultural industry group, formerly known as the American Nursery and Landscape Association, as well as the American Florists. The other entities, such as the various bodies that have to do with lumber certification, the Customs and Border Protection, as well as their Canadian partners up at Canadian Border Protection Services. All of these folks are not traditional, so I would say research partners, but they are crucial partners in the Continental Dialogue's space of making sure that we understand where is attention needed. What does both private and public, where do the private and public entities feel like things are falling through the cracks, things are not being properly addressed? When you ask different parties this question, you're going to get different answers. When you ask, for instance, an environmental nonprofit like the Nature Conservancy, what's falling through the cracks, you're going to get a dramatically different answer than, for instance, folks that do international shipping and are having significant issues with pest interceptions on their goods that are causing them, tremendous economic losses. From the perspective of the environmental nonprofit, that's an issue because you've got forest pests that could be coming in on the international supply chain. From the international supply chain player, that's an issue because they feel like they're getting a lot of penalties for a situation they don't really understand very well, and they maybe don't understand the importance of preventing those forest pests in the first place. So you get these multiple perspectives on the same problem, and that's the beauty of having a multi-entity partnership and a forum in which you can express all of your different views and opinions, as well as perspectives to see what do we need to do to reduce the number of forest pests entering the United States and Canada and Mexico, as well as spreading once they have arrived and been established over time. So then you end up with a whole nother layer on top of that, which is within those spaces where you believe attention and action are needed in the larger viewpoint, where does the Nature Conservancy have the most opportunity as a nonprofit in this space with its history and its abilities and strengths and limitations? Where does it have a role to play as opposed to other entities? So there's work that the Nature Conservancy knows should be done, but also knows they're not the best ones to do it. So some projects may not be best suited for the Nature Conservancy, and they might be best suited for the Nature Conservancy to connect with, for instance, Forest Service research stations in order to say, we're really hoping that you can focus on this in the future. We see a real gap here. And that isn't outside of the normal action of the Continental Dialogue. In fact, it's basically the way that it functions the best, because as a partner, it can the Nature Conservancy can work with all the different members of the dialogue in order to identify those places where focus is needed. Further, in the strategic planning process, we have to ask, well, of all the different places that we could focus our attention, how does the Continental Dialogue itself function as a group in a way that gives it the most ability to abate this threat? So what's the best format? What's the best way to get at the problems, and which problems are the ones that the dialogue, not the Nature Conservancy, but the dialogue is best suited to tackle? Now, these are big fuzzy questions that certainly we're not going to get to the answers of in this presentation that I'm giving right now, but this is what we've been tackling for the last few months through a lot of sort of listening sessions, as well as 2 separate working groups that some of the members of this webinar have probably been participating in and others not yet, but it's a long process, so we might get to you soon. Now, for those of you who prefer a flow chart, we also have this handy, brightly colored flow chart in order to help you out. So you can see on the far left, the Continental Dialogue has been attempting, or excuse me, the Nature Conservancy has been attempting to first identify the whole universe of North American pests and pathogens. What is the whole thing, soup to nuts, so that we can scope, and this is within our jargon of how we build strategic plans, the strategic focal areas. So basically, what are we going to focus on? And then which of those potential focus areas in pink on the left are the ones that the Nature Conservancy really feels like are in need of focus, as well as what are the ones where they really are appropriate for an entirely separate entity? So that's a valid question that perhaps neither the Nature Conservancy nor the Continental Dialogue is the correct entity to focus on that particular issue. Then we're going to sort of do the where the magic happens center part, which is what it says, the Nature Conservancy strategic planning process. That's webinars like this, lots of listening sessions, lots of iterative conversations. And then finally, we'll come up with strategic actions that both the Nature Conservancy independently will be conducting, as well as those that the Continental Dialogue will be directed towards starting in 2022. Now, if you look at the bottom, there's a lot of different ways to set the priorities. So you can use criteria like importance and impact and influence, which was brought to us by our Forest Service partners as one of the ways that they look at how to set priorities. And then there's another way of phrasing that, which is the benefit, the feasibility, and the opportunity. That was a different partner. Forgive me for not remembering who brought that one to us, but there's a lot of ways to sort of decide how to slice and dice this picture into manageable pieces that you can actually take action on. All of them are important because, you can have a lot of opportunity in a space that doesn't have a lot of impact, and that may or may not be a solid choice. It might be that it is the best place for you to take action, and you just accept that it's one part of a much larger portfolio, or it might be that you have an opportunity to take a higher impact action. These are decisions that we all make day to day in our working lives, and we're trying to be really strategic about how we hope to do them for the Nature Conservancy and the Continental Dialogue moving forward through this larger strategic planning process. So I thought I'd give you a little glimpse of the complexity of the forest, of the universe that we've been covering for the Continental Dialogue and the Nature Conservancy's strategic planning process. I wanted to first off say thank you so much to the over 30 people that have advised on this preliminary stage of our scoping effort. It's a really overwhelming amount of conceptual work. And I don't want you to spend a lot of time reading this. I should have made it even smaller so it was physically impossible to read it. But I do have it up here because during the discussion that will follow my formal presentation, I will bring it back up and I would be happy to discuss it. But the basic concept is starting overseas all the way to the long-term management. What are we going to be focusing on is pieces in here, but not all the pieces. And when I said earlier that we had 5 separate zones that we had sort of looked at so that we could divide up the world into pieces that make sense in the first place, those 5 zones that I talked about were prevention, and we sort of nailed down some of the major groupings within prevention. Early detection and arrival spaces, like I talked about. So ports that are traditional ports, as well as entry points past the ports, that's hard to say. And then things like sentinel gardens and urban areas for early detection and arrival spaces. And again, I'm going to flip through these pretty quickly because I think they're going to be much more productive during discussion than they are during a presentation format. But I wanted to make sure everybody saw that we have them here. Then in initial establishment, that's the third step that I showed in that blue sky slide earlier. We talked about what sorts of programs are important in the space of when things are starting to actually become established in North America. And we have an increasing need to deal with it before we end up in the next phase, which is management. So the management of forest pests between the early and ongoing stages where pests have localized geographies all the way to the naturalized phase where pests have much larger geographies and are operating in the ecosystem at large. Those are the steps that we also think the Nature Conservancy has a lot of value to offer within forest pests to make sure that between the science and the advocacy and also the tremendous amount of land holdings that the Nature Conservancy has, we really have a lot of space to work in this framework for the forest pest continuum. Now, these are not the only ways by any means. Oop, wrong slide. Let me back up just a little bit here. Where'd it go? There we go. These are the same 5 points. These are not the only ways to consider how a framework can be built. And I did take a moment and I accidentally glazed past it to write down some other sort of conceptual frameworks that people use. An institutional based model, for instance, would start with actions by the United Nations under the body of the IPPC, which is the International Plant Protection Convention. So that's the overseas, the prevention aspect. And then as a secondary layer of prevention, Customs and Border Protection or Canadian Border Protection Services, et cetera, operate in that institutional model. And then in the United States, then the next steps would be USDA APHIS, at which point there is a threshold in forest pests historically where USDA APHIS sort of transitions its authority and its space to the Forest Service over time, as well as geography. That does tend to happen. And then there's a fuzzy line between where the Forest Service then starts to work more explicitly with state, private forestry, and even nonprofit land ownership like the Nature Conservancy. So that's the same framework that we're looking at here, but it's from an institutional perspective as opposed to stages of invasiveness perspective. Additionally, USDA APHIS describes its discrete role in this space within part of its mission and goal statement as the safeguarding continuum. So you might be familiar with their public phrasing of abroad, at the border, or across the nation. That's one of the ways that USDA APHIS defines this. More sort of scientifically, they also sometimes use the terminology prevention, detection, and mitigation. So all of these frameworks are valid, and we've been trying to figure out how to take sort of the best and what applies best to the entire picture from start to finish as you move across different entities that are interested in forest pests. So let me just pop back over to where I was. Here we go. Looks like I'm finishing just a little early, so that's exciting. I wanted to say, first of all, thank you to everybody who is currently logged on. I really appreciate it. And special thanks to our funding agencies for this work, which are the U.S. Forest Service and USDA APHIS. They continue their support of the Nature Conservancy's work on forest pests and are incredibly valuable partners in both partnership and funding. So I would like to open up my time for questions, comments, etc. Please type them into the chat or the question and answer. And remember to ask Laurel, if possible, to unmute you if you would like to present your question verbally. And I'm going to open up the chat. I kept it closed so I didn't get too distracted. So let's get started.
So
Hey Lee, there's a question here from Margaret Allen. She asked, does Nature Conservancy keep a list of the most serious continental pests?
That's an excellent question. We have a list of, okay, well, first of all, we do not have a ranked list. Let me be straight with, we do not have a ranked list. We do maintain a public list of pests of interests that is housed by the Don't Move Firewood campaign. Some of those pests are not spread by firewood. We simply use that website as a way to list all of the forest pests. But in order to talk about what's most serious, you have to bring your values up front. And most serious, and I'm not discouraging the question at all, it's a really key question. Most serious is sometimes defined by who you are, where you live, what you grow, if you're involved in agriculture, what sorts of funding you have. You know, the ranking of these sorts of pests can be extraordinarily heavy in terms of your cultural and financial needs. And so it would be really difficult. You can certainly create like a top 10, but even that will be partially considered through the framework of your own part of the country, for instance. So it's a really difficult question. Dr. Songlin Fei at Purdue University put out a recent paper. I want to say, I think it came out in 2020, but somebody can correct me if I'm wrong, please, in the chat. And he did actually pick the top 10 that he thought was most impactful for the purposes of his biomass research. And I thought it was an excellent list. So if you're looking for a quick US-based top 10 concerns, Dr. Songlin's Fei paper would be a great reference, for instance. But the Nature Conservancy does not maintain a list like that. There we go. Yes, the subjective part is incredibly important, and it's actually really, it's a really difficult thing to get your hands around because not only is it geography and climate change based, but it's also cultural. So Gary Fish, who, if memory serves, is from Maine, says, don't forget about the state quarantines and the National Plant Board cooperation. And that's a really great point. So Gary is reminding me that when I was talking about the forest pest continuum from the institutional standpoint, which is a little bit different than the Continental Dialogue itself, but it's worth sort of structuring the conversation there. The institutional standpoint, once you get after CBP, for instance, but closer to Forest Service, state, private, nonprofit, et cetera, you get into the needs for state agencies to have quarantines or make decisions not to have quarantines according to their priorities, and the National Plant Board, which is the body of all the state plant regulatory officials across the United States so that they cooperate and also information share to make sure that the forest pests are addressed with the most efficient approach. You wouldn't want, two states to conduct the same research, for instance. So the National Plant Board is an outstanding venue for that sort of cross-state coordination. So thank you, Gary, for mentioning that. If anybody has a question that they want to present verbally, remember, just ask Laurel to take you off of mute. Or you can put it in the chat. And then anyone else?
Lee, I can't remember, this is Erin, if you addressed this, but what is the timeline for your overall planning process? And where, I guess, else would you envision seeking input in the future, knowing probably people would have liked to attend today that couldn't make it?
Yeah, absolutely. So we had hoped to wrap up the research and primary prioritization in December. We got started in August, just so you all know. But as everyone knows, it's really hard to stick to deadlines in the fall, and various delays occurred. And so we're hoping to get through the basic prioritization now in January, and then the write-up and sort of finality and peer review in probably February and March for the final product. Erin, your other question was how can people participate? The best way to participate right now in terms of priority settings is to send me emails as to what your priorities are. I am actively going through those tremendously wordy slides, basically in my own format, to make sure that I understand the different priorities, and I'm bringing those to both. Well, actually, at this stage, I'm bringing those to the Nature Conservancy's internal experts beyond myself. So we have experts in forest health from the non-forest pest perspective, as well as carbon sequestration, as well as land utilization, that are helping me with this process. So if you have questions or comments, please email me directly. I'll make sure my email's in the chat. And if you don't have it, if you're watching this later and you can't see the chat, my email is lgreenwood@tnc.org. That would be the best way to get a hold of us during the strategic planning process. I see one more question from Yuri and then one question from Margaret Allen on my chat. So I'm going to do them in that order. Yuri says, ultimately, this is a matter of national priorities. Yes, I'm not 100% sure on, do you mean, can the Nature Conservancy, affect the national priorities at the USDA level? But I think the Continental Dialogue can, so I'm going to go with that. So does TNC engage in communications about that? Yuri, I'm going to have you take yourself off mute and help me better understand the question, please. And then Margaret, I will get to your question about the Chestnut Foundation.
Hi, everyone. This is Yuri, University of Florida. Yes, it was interesting that in your list of 5 priorities, they're very sort of management and response focused. But ultimately, if you talk to most people, be it, the Joe from the street to elected officials, they don't know about this. And it's hard to prioritize that in their lives or in the national spending or in contributions to the TNC or any other agency. Yeah. if people don't know about this and they don't know that this is a massive issue.
Yes.
And so my question was, does TNC engage in any sort of communications like that?
We try to as much as possible. And it's this is a really good question. I was misinterpreting the question, so I'm really glad you clarified it for me. The Nature Conservancy is increasingly attempting to communicate on the importance of forest health from the hook of the forest carbon perspective. For various reasons, both institutionally as well as nationally. Forest pests have been a difficult place to get a lot of political and national level attention, like I think you're alluding to. But from the forest carbon perspective, from the importance of all of the forest sequestration conversations that are occurring locally right now, we're really putting in a lot of push as to say, you can plant all the trees you want and you can protect all the land you want, but if you don't prevent forest pests and pathogens from either killing or grievously harming and slowing the growth of those forests over time, you will not reach your carbon sequestration goals, and your management of the carbon balance of the globe will not be as easy to achieve. Your goals will be more challenging because you fail to take into account one of the biggest threats to trees, which is invasive forest pests. So we've been very much pushing that from the national level and really trying to do our best to get the attention to that it deserves. So yes, and Gary Fish adds that yes, states are also trying to look at this perspective from the climate change perspective. Those are very great examples, Gary, thank you. So I'm just gonna finish up and then hand this to Erin to do a brief introduction for Yuri, but Margaret Allen asked, does TNC cooperate with the American Chestnut Foundation? Absolutely. They actually are giving a presentation next week for this webinar series. Sarah Fitzsimmons from the American Chestnut Foundation will be giving a presentation, I believe Wednesday, but it might be Tuesday. You should check the schedule to make sure. And we have indeed looked into their new breeding techniques and the need for genetic restoration on certain types of host trees is absolutely part of our strategic planning process, including the American chestnut. So there you go. Erin, it's all you.
Great, thank you. So with that, I'm going to give a quick overview of Dr. Yuri Hulser's work. So Yuri, thank you so much for joining us today. He's an associate professor at the School of Forest Resources and Conservation at the University of Florida. His research interest started when he was quite young, with beetles around his home in a small rural town in the Czech Republic, where he walked 3 miles each way to school and back. He earned 2 doctorates in entomology from Michigan State University and from the University of South Bohemia in the Czech Republic. Following a couple of postdocs, he began as an associate professor at Florida in 2012. He and his lab study the evolution and systematics of insects, as well as how tree-killing symbiosis is impacting trees, forests, and people. In particular, his work focuses on symbioses between organisms, big and small, fungi and insects that farm those fungi, between fungi and bacteria that live inside of those fungi, and between bacteria and people who are largely oblivious to the importance of bacteria and their bodily functions. And in fact, it seems some of his postdoctoral work focused on belly button microbiomes, which I'm interested in learning more about at some other time. But today he's really here to be talking about a different area of subject matter expertise of his, which is international cooperation and risk analysis. So with that, thank you for joining us, and I'm going to turn it over to Yuri.
Hi, everyone. Thanks, Erin. I appreciate the introduction. I'm going to have to ask you where you get all that information. But later, indeed. I will just get started with sharing my screen. I think I was given 15 minutes. I don't know how I'm going to pack that all into 15 minutes, but let's try. So what I will be talking about is cooperation on pre-invasion assessment of Asian wood borers. That's what my lab focuses on. And I think everybody who is on this call doesn't need the long introduction of why invasive bugs matter. I will simply summarize that there are a lot of them, and very few of them were suspected to be anything like a invasive pest or high priority pest before they showed up. So what my lab does is we're asking a question. Is there a threat to Florida's trees on the horizon? Meaning, are there any imminent high importance threats in terms of wood borers specifically on that might arrive via the international trade? And so we do that through several steps from several perspectives. First, we ask whether there are any pest reports from overseas that we need to be on alert about. We deploy sentinel gardens in Asia, American trees planted in Asia to detect potential pests. We study the pathogens or the fungi associated with these beetles. We use the biology data to model and predict the risk, and we communicate that with agencies. Let's go first with the first priority, the first method, which is that we work with overseas scientists to get at the pest reports there. And how do we do that? Well, first and most important of all, this is about cooperation. And so it's about building trust. How do we do that? Well, we go there. We spend a lot of time in the field and in institutions in various places in Asia. We provide our expertise. We provide a little bit of funding, but mostly they don't need that anymore from us. We share publications. And what we get in exchange is local help. We get more friends. We spread the network, spread the word, and we get pest reports. And that is the most important thing for us. So after we build trust, we also try to exchange information. We offer information. You know, often it seems like, from our perspective, that there are these pests raining on the United States from elsewhere. You know, it goes both ways. We've introduced so many pests already in Asia that created so much ecological and economic damage. And so we are trying to create this information flow. So we've created this Asian Forest Health program funded by the Forest Service International Programs. Thank you very much. It is sort of summarized on our website, the Asian Forest Health, and that is a bilingual website. We actually have translation folks on staff. It's not just the Google Translate automatically. And we inform people about what it's all about. We also employ video. We sort of introduce people into these questions, such as how this collaboration can work, how to collect these pests, not just secondary ones, and, you know, methodology videos and that kind of thing. We build intentionally social networks across Asia to facilitate this information flow. We work with multiple platforms. WeChat is pretty much at this point the only one left that works in China, so we focus on that. But we also work with LinkedIn and Twitter. We have hundreds of members. These numbers are a little bit old. And you know, these are folks who are actively interested in forest health. So these are substantial numbers. We used to go to conferences when it was still possible. This is sort of a nostalgic photo. You know, this is 2.5 years old. This is a little group that includes Forest Service folks in our lab, but we're looking forward to the time when we can do that again. We distribute free collecting kits to anyone who asks. If you're a student or a forest health manager, anyone in Asia who is interested in looking at bugs and reporting them, we'll send you the kit that includes things like a box cutter and preservation fluid and this is a little lens for a smartphone, so you can take photos and send them to us, submit them, that kind of stuff. The results are reports of aggressive beetles.
In collaboration with our colleagues in China, my team discovered a bark beetle that kills the American sweet gum. It is called the sweet gum inscriber. A tiny beetle, but it attacks our sweet gum in masses. This is what happens to American sweet gums that are planted here in China. Here is the biggest trouble. Look at this picture again. Right behind this levee is the magnificent Yangtze River, the largest export hub in China, and a quick route directly to the rest of the world. Just a few steps from logs teeming with aggressive sweet gum beetles. Just imagine our southeastern forests if this bug got a ride on one of these container ships.
So this is an example, the sweet gum beetle that many of you have already heard of, is an example of the fact that several exceptional beetle and fungus species can indeed kill living American trees. And we work with colleagues overseas to find out about them before they show up. Our second approach is the sentinel gardens. Again, I don't have to explain to you probably, I think all of you probably know what it is very well. It's we are planting trees overseas, American tree species or trees that are of interest to American industries. And we are attracting borers that are potentially attacking living healthy trees or perhaps stressed trees. We are looking into all wood borer taxa, that is bark beetles, cerambicids and such, and we're using key commodities. I'm not listing the trees. You were continuously expanding the list of trees. Again, we're working with the Forest Service, particularly the International Programs Group. Again, thank you very much. And currently we have 4 different gardens in different latitudes and altitudes. And the project is ramping up, so stay tuned. I will just present very quickly the results we have so far. These are different sites from different provinces. These are the species of insects that we have recorded attacking our living trees. And there are some that are not surprising. We know that the Anaplophora chinensis, or the citrus longhorn beetle, like citrus. It was nice to see that confirmed. It was nice to see that our approach indeed works in finding these borers. This beetle is not yet in the United States, but it is known that it's a major pest of citrus. But what we also found out is that the same beetle oviposits on American oaks. This is red oak. And look what it does. This beetle, this is a female that goes down to the base of our planted oak. And this is a living oak that's relatively happy. The female goes down, chews a oviposition niche through the bark, and then she turns around and lays an egg in there. And we are actually rearing these beetles from the trees. And needless to say, the tree is not going to be happy. So we are finding out the beetles that we really don't want in the United States. Another example are these tiny little bark beetles called Cryphallus. And you can see one here chewing its way into living slash pine. The interesting thing is that these are from 2 different sites, 2 different provinces, and these numbers are pretty significant. This is not like 1 or 2 cases. These are, at this point, dozens of pines that were eliminated by these Cryphallus beetles. Again, something to be on the lookout for. Okay, so these were the sentinel gardens. Our third approach is inviting institutions and individuals to provide or share beetle-associated fungi. And the majority of them are not really provided to us. We have to go there and grab them. So there are 2 ways to work with these pathogens. Either we work with overseas partners that enable us to collect these beetles, or we get the strains directly from them. Regardless, we grow the fungi in a quarantine situation here in Florida and inoculate them into the test pines. This was done mostly, so far it was done in oaks and pines. After 5 years of work, I'm happy to say that it's finally out. This was a humongous collaboration of many different institutions around the world. And we've tested 111 fungal strains, all isolated from bark and ambrosia beetles from across Europe and Asia. And almost all of them are harmless. And this is sort of what we've expected. 99 of the 111 do absolutely nothing to the trees. 12 of them are mild pathogens. They cause mild lesions. So we want to keep an eye on those, because if many beetles inoculate them, that may be an issue. The best news is that none of them was a tree-killing systemic virulent pathogen. So we were really originally testing if there's something like the laurel wilt fungus or the Dutch elm disease fungus that would hit our pines or oaks. We're not seeing that. So far, that's good news. All this data then feeds risk analysis. This is something we work on with the APHIS, USDA APHIS, the risk analysis group. So thank you for that collaboration. Essentially, this amounts to working out a model. The APHIS has already designed a really amazing model called the OPEP model, the Objective Prioritization of Exotic Pests. And it's a bunch of variables. Right now, we have modified it, the formerly agricultural pest model, to wood borer model. We have 54 variables that each wood borer needs to be scored for. And that allows you to model the probability of impact. And, you know, like this one, for example, the majority of the prediction falls outside of the scope of medium or high impact. So this particular beetle, I don't know what that is, would be a good news. But there may not be all good news. So essentially, this allows us to fairly empirically support decisions about action against new invasive species. Like this, you know, hazy beetle. Who knows what that is, what's waiting out there. These are the unknown unknowns. And what happens then if we identify a high priority wood borer? What do we do then? It has to be communicated. This is the key element that most, I admit, even us, but most scientists sort of forget, that the communication is critical. So right now we're hoping to work with the USDA on new pest response guidelines, which is their sort of most important internal set of information that aid in decision making, and we're hoping to work on that directly with the agency. But to sort of conclude, I just wanted to say a few words about the partnerships, because that is what this webinar is really all about. We have, over the last couple of years, developed a lot of partnerships, mostly in Asia, some in Europe and elsewhere, with very many different universities and research institutes and individuals in a place that is not always politically friendly to us. We have also developed very nice partnerships with US agencies, both in terms of expertise and in support. And I'm really grateful for that, because without that, obviously, we wouldn't do the first thing. We are also working with Florida state agencies. And here, I admit that it's not as easy, and I don't know if there is anyone from the Florida state, but I'd love to talk about that some more, because, you know, while Florida is the sort of cradle of the fiber and timber industry, besides Georgia and Alabama in the Southeast, the support is rather limited to the research and monitoring of potentially invasive insects. For those who are outside of the university systems, I wonder how you often see, you know, the existence of these efforts within universities. I think it might seem like the universities are a homogeneous organizations. Well, they're not. It is, you know, collaboration or partnerships within universities sometimes may seem more like a battlefield, and so we have to be constantly developing relationships with our university research, the highest level, with the compliance about international collaborations, with our college dean, our internal college compliance officers, and so on. It's actually not easy. I just wanted to conclude that, you know, if folks imagine that partnerships save you work, they don't. Partnerships really mean a lot more work. It means that you don't really share the effort with any of these partners. We assume, and this is how it always is, that we do 95% of the work on each of these partnerships. Partners don't really necessarily, you know, do the job for us. They enable us to do it, but it's us, or let's say you, who actually has to go out into the field and catch these bugs or fungi. But these partnerships enable us to do this stuff, to do feats that are impossible to be done alone. So it's not necessarily help in terms of effort, but it extends the realm of possibilities. And here's one last thing that I don't know how, I would be curious what people think about this, but some of you may know what this means. This is sort of the symbol of the big brother looking at what we're doing and whether we are, behaving properly and everything. The legal and regulatory structures in which this research exists, the structures are becoming increasingly difficult. I would love to talk about that a little bit more, but the relationships that we as the nation or as the academic and nonprofit world are building with the rest of the world are not necessarily always friendly, and it's becoming really difficult to do this kind of research and building these partnerships with the rest of the world, and that is particularly in China, I gotta say. So would love to talk about that some more. Thank you very much, everyone. And I will take your questions.
Thanks, Yuri. That was fantastic. And that video of the citrus longhorn, beetle, I just want to say is remarkable.
Isn't it scary?
I've never seen such an excellent video of that behavior. It was really, really remarkable. Did you take that yourself?
No, that was a student of mine.
Oh, we gotta send that student some sort of a appreciation note.
But I agree. This is crazy. We can produce tables and tables and tables of data like that.
Yes.
Nobody cares. And then we actually document it with video. We document how the bug is chewing up an oak, and suddenly it rings a bell. Suddenly people realize, that oak is in my garden. What if that beetle shows up here? This is what's going to happen. And that's exactly when I originally talked about communication.
Yes.
I really think that the whole invasion ecology, I should say that our efforts on curbing the impact of invasive species are one big communication tragedy, because we are not really, as a community, we're not taking seriously the power of communication with people, with many different layers of the society and such. Your point is well taken, that videos are cool.
I just wanted to hop on too to say, can I get a copy of that when I'm meeting with Florida offices? I do think video is so powerful, and it's easier for people to visualize.
I would be happy to share everything if you take me with you, because I would love to meet with Florida officers with you and talk about this at length.
Done. Thank you for volunteering.
Go
Happy to.
ahead, Erin, sorry.
I was just going to say, one of the biggest challenges with getting this on people's radar is that it isn't until things have already become established and they're spread all over the state that it winds up on politicians' radars. And so it's an ongoing challenge for those of us that advocate for doing something before they get to our shores to really make the case there. And it's an ongoing experiment to figure out what resonates and how to get that across. But talking about the threats to commodities and crops and horticulture sometimes gets on people's radar, at least.
Yeah, for sure. And I was going to add too, citrus longhorn beetle is such an interesting case, because we did actually have one historical incident of citrus longhorn beetle in Washington state that emerged from an imported bonsai tree, of all things, in a nursery environment, and was successfully contained. And had there been an infestation at that time, it was eradicated. The reality is that because of the uncertainties, they don't know if actually more individuals, they don't know decisively how many individuals entered the environment. So it's unclear exactly how challenging of an infestation they might have been dealing with at that time. This was quite some time ago. I want to say late 1990s. But it really speaks to how important the flashiness of those bugs is. Somebody noticed that thing crawling out of that bonsai tree, just like that video that your student, or the student with the project took, is so flashy with that large insect, and those sort of spokesperson type creatures can be really, really influential.
On that note, if I may, if the citrus longhorn beetle shows up, we can already have a good precedent, because I'm sure you know of the Asian longhorn beetle, terrible common name, that is wreaking havoc elsewhere. I notice Dave Coyle is here on the call. Folks are trying to fight with that in South Carolina now and elsewhere in the Northeast. But imagine if those little tiny boogers, the little Cryphilus bark beetles show up, or the sweet gum beetle. Nobody knows even how to identify them. And when these things fly around, they look like midges. That's when we really run into the realization that I admit I am very, very skeptical of any attempt to stop or manage these bugs after they get out of hand. I would love to see a successful attempt anywhere in the world where it has helped. Please give me some optimistic stories, because I don't see very many. I do think that we have to focus all our efforts on pre-invasion awareness and screening and screening at the borders and making the community alert and aware, reporting and that kind of thing. We know a lot of these bugs already. You know, the research has moved on from like the 20 years ago when people were throwing around the word unknown unknowns from, you know, the sort of the military jargon into our field. Well, there is plenty of unknown unknowns, but there's already also plenty of known unknowns or known knowns. Like, we know a lot of these bugs. We know a lot of these fungi. We still have a problem with many unknown ones, but we also have a problem with many of the potential insects that will cause damage when they show up here, and we're still not ready.
Right. Yes, and an excellent example of that is the last decade that was spent successfully eradicating the giant African land snail from the greater Miami area. I mean,
right.
Snail that actually reaches the size of like a small rabbit. And the fact that it had, evaded detection for as long as it did is almost the exception that proves the rule with how difficult it is to tackle these issues when they are literally or figuratively small.
I just want to give kudos to the state of Florida on this one.
Oh, that's an amazing
right.
achievement.
The state has actually, I mean, this is another crazy communication, sort of lack of communication, because here in Florida, the agriculture part of or the focus on agricultural pests is incredibly effective in monitoring and detecting and squishing incipient outbreaks of exotic bugs. And that's, from the snails, that's the fruit flies and many of those, really effective. But in terms of forests, I don't see any.
Yes, and for the record, I do want to indicate to all of our listeners, I'm well aware that snails are not insects. So for anybody who's just like, really? Anyway, well, on that joke, I see that Yuri, your time is up. Do you have any last comments before Aaron does an introduction for Angela?
I have so many comments that we should just keep going.
Okay.
All right, well, thank you, Yuri. And with that, I am going to give a brief introduction to Angela as she's pulling up her slides. So Dr. Angela Meck is an assistant professor of forest entomology at the University of Maine. She earned her PhD at the University of Georgia in the lab of Dr. Kamal Gandhi, who's actually been a huge resource for me as I've been getting up to speed on these issues. She and her lab are conducting research on methods to reduce the population of the brown-tailed moth. And for those unfamiliar with these critters, they create a highly irritating type of contact dermatitis, as well as respiratory issues from encounters with the tiny hairs on their bodies. So they're really highly problematic for residents in Maine and the area. Her lab aims to prevent future outbreaks by releasing a female pheromone, which will confuse the males and reduce mating, which is really cool. So they're working to identify the most effective pheromones and produce a synthetic version. I also owe Angela a huge thank you, because in August, we hosted a webinar with Senator Angus King, who is the independent senator from Maine. And he's been a great supporter of our work at the Entomological Society of America. And he mentioned the challenges that he's been dealing with, that he's had an encounter with these moths himself. And so afterwards, Angela reached out to his office, and I knew somebody had reached out, but I didn't know who. So thank you, Angela, for helping with our outreach efforts. I really appreciate it. And I've held it up as a gold standard of why it's worth our time and energy to do these kind of webinars. So with that, I'm going to turn it over to Angela and thank her again for participating today.
Well, thank you, Erin. That was I'm a little flustered from that introduction. Thank you very much. And thank you for inviting me to talk with you all today. I really like the idea of this collaboration of speakers that really discuss this pre-invasion awareness. And so I've kept an eye on Yuri's work, and I've really enjoyed it and jumped on in time to see some of those results, and it's really super exciting. And I see how there's many groups that are looking at multiple aspects of being able to determine this risk affiliated with species that aren't quite here yet. So I was asked to talk about this high impact insect invasion working group. And so I need to rewind a little bit and talk about 2016. So the group initially got together, the folks here in bold were the original PIs of this working group. And it was comprised of forest entomologists, plant biologists, quantitative ecologists. And then I was the little postdoc on the project. After I left Georgia, I went out to the University of Washington and worked with Patrick Tobin on this project. And we worked together. We were funded by the USGS Powell Center for Analysis and Synthesis. So it's this great program where they put everybody in a room for a week. They feed you, so you don't even have to leave to go out to lunch, and you just hunker down and really try to come up with these great ideas and answers to questions that have been bothering fields. So we worked for 2 years, which wasn't quite enough because these questions are way too big. And so in 2018, we kept many of the faces, we got some new faces, and we acquired funding from the National Urban and Community Forestry Advisory Council. So this was a NUCFEC program for 2 years. And again, we all got together, and our postdoc this time, because I had moved on, was Ashley Schulz, who worked with Ruth Huffbauer at Colorado State. And now Ashley's actually moved on and just started a new position at Mississippi State. So all of us basically were getting together to try and answer that $1 million pivotal question that we've been asking for over 100 years, which is, what is it about non-native insects and why some of them wreak havoc on systems and cause significant mortality and damage, and other ones, the majority of them, don't do anything. So although we know that insects can devastate tree hosts, we haven't had a simple answer as to why. We have the enemy escape hypothesis, we have the defense-free space hypothesis, and they all have a lot of data to support them, but it's not as simple as that because we do have species that don't do anything when we might think that they would. So our group sat together in a room for a week and basically tried to figure out how can we predict the next high impact insect invaders. So what factors are driving the level of impact of these non-native species and causing some of them to be widespread mortality and others don't do anything. And when you put 15, 20 people, most of them seasoned scientists and experts in their field, and you put them in a room, they can come up with a lot of hypotheses. And in fact, I think we came up with over 50 at that initial meeting. But luckily, they all kind of fell naturally into these 4 categories. And so we thought, well, maybe it has something to do with the insect or something to do with the tree host itself, some component of the tree host. And then we were interested in the evolutionary history. So both between the insect's native host and the novel host here in North America, and then the evolutionary history between the insect and what is native here in North America and co-evolved with our tree hosts. And so we basically hypothesized that it was probably going to be a combination of these factors, that there's no simple answer, that it's probably a combination, and that's why it's been difficult to tease apart. So first things first, we had to develop an impact scale. So we keep saying these high impact species. Well, what exactly is high impact? So we came up with this nine level scale where low impact species are those that don't end up killing the host. So they can cause minor damage, leaf dieback, branch flagging, stuff like that. Or we found absolutely nothing in the literature. Medium impact were those species that have been recorded to be associated with killing an individual tree. And then high impact species are those that can kill multiple trees within a population and either outbreaks or a continuous range expansion all the way up to functional extinction of the host. Now, for our purposes, and most folks, this is the group that we're interested in. The ones that medium impact, low impact, not as much of an issue there. And so for our purposes, we basically separated it into high impact or it's not high impact. So for our methods, what we did is we looked at all of the non-native species that are currently here in North America. And we wanted to look to see if there was any traits or factors associated with those insects in the trees that they attack here in North America and their level of impact. So our first part was sort of a pilot study because there's 500 non-native species in our forests, and that's a lot of work for a poor little postdoc. So we opted to just start with conifer specialists. So these were insects that only utilize trees that are conifers, so Pinaceae, Cupressaceae, Taxaceae. Once we completed the pilot study, we expanded that to hardwood specialists and then added the generalists and looked at all 3 categories of non-native insects in North America. So for each of those categories, conifer specialists, hardwood specialists, we looked at the 4 main groups of interest. So we were interested in the insect traits. So for the 58 conifer specialists that we identified, we went through the literature and read as much as we possibly could to determine, okay, what's its feeding guild? What is its reproductive strategy? Its fecundity? Do any of these traits influence its level of impact? Is it as simple as if it's a pest in its native range, it will be a pest here? For the North American host traits, we looked at, for the pilot study, for example, all of the conifer trees that are attacked by a non-native species and determined its level of shade tolerance, foliage texture, drought tolerance, all of these traits that can be biologically connected to levels of defense, for example. For the native and novel host evolutionary history, we dug through the literature and found every native host for that non-native species, and then all of the hosts that it attacks in North America. And we identified the most recent common ancestor for every North American tree that it attacked and came up with that divergence time because we were curious if that drives impact. And then for the native and novel insect evolutionary history, for all of the North American trees that were attacked, we created a massive database of native insects that co-evolved with that tree. And what we basically wanted to look at was whether or not there is a congener that co-evolved with that tree. So if there's a non-native insect attacking a red oak, is there a congener that did co-evolve with that tree already associated with it? Or is there a member in the same family if there isn't a congener? If there isn't a congener or family, is there something in the shared order? And we looked at that taxonomic hierarchy and modeled that to see if that influenced impact. So for our conifer specialists, as I mentioned, we identified 58 species of non-native conifer specialists. And when we looked at insect traits, all those insect traits, nothing came out to be significant, either individually or in combination, which we kind of expected, because if it was as simple as it's a pest there, it will be a pest here, we probably would have figured that out by now. When we looked at host traits, we did find a significant effect. And so each dot on this graph indicates a different conifer species. And then risk is increasing from left to right here on the x-axis. And we saw these 2 clusters kind of, where there was a cluster of trees that kind of had a higher risk of experiencing a high impact insect invasion. And it turns out that all of these trees had high shade tolerance, and most of them had low drought tolerance. And so there's some aspect of that combination that increased the risk of experiencing high impact from a non-native insect. When we looked at that evolutionary history between the insect's native host and the North American host it attacks, we found a quadratic relationship. So if the trees were too closely related, there wasn't a very high risk. In fact, it was practically zero, as well as too distantly related. But if the trees fell, the divergence time fell within what we refer to as the sour spot, that those trees that diverged in that sour spot seem to be more susceptible to experiencing high impact. And so we think perhaps the trees that are closely related still share a lot of the same host defenses, and trees that are too distantly related are probably too distantly related for the insect to utilize successfully. But if it's within that sweet spot, then perhaps the North American host has released some of that defense pressure on itself, and so the insect is able to succeed more. We did find that there was a significant interaction with feeding guild, and so this up top is folivores were more sensitive to trees that were more closely related, versus sap feeders was a little bit later on the divergence timescale. And then we looked at the insect relatedness and found that there was a 10-fold difference whether there was a congener that co-evolved with that particular tree. So a congener seemed to decrease the likelihood that a non-native species would cause high impact. And it could be because of competition. It could be because the host is basically used to that level and type of feeding from something very closely related to the non-native species. Or it could be that the non-native species is utilized by our native congeners' natural enemies. But in either case, that was found to have a 10% higher chance if there was no congener that co-evolved with the native host, or sorry, the North American host. So as we mentioned, our hypothesis was, well, we bet it's a merged thing. It's multiple factors coming together, that it's not just one of these three categories. And so this is an ROC AUC curve, which is basically showing if we've randomly selected a high impact tree insect pair and a non-high impact tree insect pair, how often did that particular model predict the right one? And so this red line here is that insect history, evolutionary history, so whether there's a congener on the tree, and you see an AUC score of 0.51. So that's barely better than flipping a coin. But if you merge that in with the host traits and the evolutionary history between the native and novel hosts into this black line, which is our composite model, we got an AUC score of 0.91, which everybody in our group kind of did a little happy dance. We were not expecting that high of a predictive power. But overall, very good when we look at all of these different aspects together, that composite model, which is up here on the right, that really does allow us to kind of open this window into figuring out what is driving insect invasion or impact. So combining the three submodels was really best. And when all was said and done, when it comes to conifer specialists, this model would be able to predict whether a species that isn't even here yet has a 1 in 6.5 chance or a 1 in 2,858 chance of being high impact if it were to invade and successfully establish. So that was really exciting when we got to see those results. So the take-home message is that there's sort of this evolutionary recipe for destruction, that it's not just if the conifer is shade tolerant and drought intolerant, but if it's also being attacked by something that it has never been attacked by anything closely related to that, and if it diverged from the insect's native host in that sour spot. So for example, balsam woolly adelgid is a prime example where balsam fir is a shade tolerant, drought intolerant tree, so it's got one bad check mark against it. The native host is Abies alba, which diverged from balsam fir 13.5 million years ago, which is right in the middle of that sour spot. And there's no co-evolved adelgids on our fir trees here. So it just had everything working against it that would all of those things combined spell a recipe for destruction for our poor fir trees. Okay, so for part two, we moved on and Ashley took over as postdoc, and we now switched to hardwood specialists. And so in North America, there are 191 species that met our definition of specialists, which in this case was, it utilizes just a single host family. And out of that, we did a stratified random sample of 100 species that matched the overall composition of guilds and orders. And we ran, and host traits was again significant, but a different host trait. So it didn't matter about shade tolerance or drought tolerance. Now it mattered about wood density. And this was also quadratic. So trees that had a moderate wood density appeared to be at a higher risk of experiencing high impacts. Host relatedness was again significant with that quadratic curve and that sour spot based on divergence time. And then insect traits had a significant trait, which was whether or not the insect was a scolytine. And so when looking at hardwood specialists, this was a big difference with conifer specialists. We have 6 scolytines that specialize on conifers. None of them are high impact. And we have 3 or more, I think it was 3 hardwood specialists that were scolytines, and 100% of them were high impact. So this did come out to be a significant insect trait. And now there was no effect of whether there was a congener that co-evolved with the tree. So looking at that composite model, we see the same pattern where it's a combination of those submodels, not individually. And this time our composite model for hardwood specialists was 0.95. So again, much better than we originally expected, but different submodel categories, whether we're talking about conifer specialist systems or hardwoods. So our last step was to add the generalists, and this took us actually a couple of years. There are 251 generalists in North America, non-native generalists. We subsampled 90 of those. And then we merged everything together. So there are 500 species non-native in our forests. We ended up evaluating 248. And one of the issues that we discussed at length is, what is this definition of specialist? Because it really depends who you talk to. Some folks, specialist is just feeding on a single genus, not family. And there are a lot of insects that may only utilize 2 families, but we had them lumped in with generalists. And some of us had kind of an issue with, having something that only utilizes 2 families be in the same category as those that utilize over 100 families. So we came up with, we decided to look in a different direction to come up with that division. And we looked at this phylogenetic diversity, or PD. So we had all insects list of native hosts. So what we did was we summed the branch lengths of the insect's native host from its native range, and basically determined that point at which, if you continue to add species that had increasing amount of PD, where did the strength in our model start to go down? And that turned out to be a PD of 2250. So insects that had a PD less than 2250, we considered sort of as specialists, and those greater than 2250 were the generalists, based on running our models and finding that level of strength. And so now that we have all of this data, we have the PD, we have our composite models. What do we do with this? And so we've been working with folks at the Dolly Lab at Dartmouth, as well as the Davy Tree Care Company. And we are creating the iTree Pest Predictor, or the ITPP tool. And so this eventually will be a part of the iTree software suite. But what we expect to kind of sort of happen is we've created these predictive models. And so a user could log in and enter data about an insect that isn't here yet. So they tell us about the feeding guild, the taxonomy, where is it from, and then what are those native host trees that it utilizes in its range. And then our model gets run in the background, and the user would receive an output of over 400 North American trees and the level of risk associated with that particular insect on that particular North American tree. So this is an example output page. The ultimate goal is to help a variety of stakeholders basically generate these risk assessments for our North American trees for species that haven't invaded yet. And I'm looking forward to implementing this in my classroom and having students help us find these species. If folks continue to enter data, all of that is going to be stored. And so we would be able to, every 5 years, basically open it up and see what species are being entered and are there any red flag ones that are coming up as this hot red zone. So for this example, I entered a species that utilized 2 or 3 elm species, only elm, in its native range. And as you can see, this particular one came out to have a 1 in 7.6 chance of being high impact on our North American elms. And this host suitability in the middle is basically letting the user know whether or not, based on how the insect behaves in its native range, if there is a high likelihood that it would utilize that particular species in North America. So it utilized elm in its native range, it will utilize, most likely it has a high likelihood of utilizing elm here. Planera aquatica has a medium likelihood. It's not in the same genus that the insect utilizes, but it is in the same family. And then those that have a low likelihood are tree species that aren't in the same family or genus that the insect utilizes in its native range. So based on what data would be entered into ITPP, it chooses the right composite model. So we had a separate model for conifer specialists and hardwood specialists, but we realized when we merged all of the data together that we actually had 5 composite models. So the first division is whether the native hosts are conifers or hardwoods. If it's conifers that are entered, it just matters if the insect is a sap feeder. If it's a sap feeder, it's a different model than if it is any of the other feeding guilds. And then if it enters into hardwood, we calculate that PD value. And if it's less than 2250, we ask if it's a scolatine. So the scolatines do have their own separate composite model versus the non-scolatine hardwood specialists. And then we have what we would refer to as the generalists. So all of this is happening in the background. And then the results, we would calculate the risk on those 400 North American conifer and hardwood trees. And so this is just another showcase as to why how these systems are different, and to reiterate that it really is about multiple factors influencing, that it isn't just one, that the composite model is the best fit for all of the different groups that we looked at. And so you can see that for conifers, shade tolerance and drought intolerance increased the risk of high impact, but actually for generalists, it decreased the level of impact on hardwoods. So different traits factored in different ways. Different feeding guilds had higher risks, whether we were looking at generalists or non-scolatine specialists. And some of the relationships for scolatines, it wasn't a quadratic relationship with evolutionary history between the host. It was actually linear, where the trees that were most closely related had the highest risk potential. So slight variability, overall composites being the most important. So in summary, all of our work that we've been spending together now for almost 6 years, we were able to kind of quantify this effect of evolutionary history as a driver of impact, particularly with the host divergence time. Important traits and factors were different based on if you were looking at conifers or hardwoods. And we looked at all 500 species to kind of pull out those high impact ones. And so we can say that the percentage is less than 5% of the non-native species cause a level of high impact. And we can use these this knowledge of these traits and factors to predict risk of species that aren't quite here yet. And the goal is to have ITPP available in 2022. We're on the final stages right now, so we're really excited to have that up and running. And all of the data that we collected to get to this point is publicly available. We have 2 of them right now. So for our 2 publications, the conifer specialists and the hardwood specialists, those databases are available through USGS ScienceBase. And with that, a number of funding sources have helped us get to this point, and a number of different folks and different agencies have been pivotal for us getting this far. So I guess with that, I will take any questions folks have. It looks like actually a couple questions came in the chat. Have we published the generalist findings? Not yet. That's our next one we're working on. It'll probably be submitted early next year. And then have any invasions been predicted? So as of right now, we haven't started to officially enter the data yet into ITPP. But we do envision that we're going to make public findings as we move through and as stuff comes through. We've been working with folks from APHIS and the, oh, I feel horrible, the Canadian version of APHIS that I can't remember the name of, and some other agencies, so CFI, sorry. So we're looking forward to having multiple folks utilize the tool, hopefully.
That was a great presentation, Angela. Oh, and I see Yuri's got a question. And I apologize if you said this because I was trying to scribble down notes really quickly. But are you able to correlate these high risk, potentially high impact non-natives with different geographic regions to help with predictions that could help? APHIS, for example, is there screening and detecting at ports?
Yeah, we did collect, we are asking folks to enter information about the climate of where that insect is found and the region that it's found in to try and climate match with our North American trees. And then we have that information for all North American trees. So that's one of the things that we might be adding to the output. And then because it's going to be a part of the iTree software suite, it's going to have links to iTree Eco and iTree Landscape, which are, if you're unfamiliar with those software, they are great. They show you where these tree species can be found, the value of these tree species in urban areas in particular, and they're really great programs. So they're going to connect. So if you get an output that says American elm as at high risk, you can then go to iTree Eco's page on American elm and learn more about that tree species and what value it has.
Very cool. Yuri?
Angela, great stuff. Thank you so much. I'm glad that somebody's putting in some data too, rather than arm waving like I do. I have a question about, I'm a little sad that you point out the scolytines as the mean guys, because that's
only for a particular group.
I have a question though for you. Because there are the great majority of the ones established in the US are harmless. Did you use those to parameterize your models?
Yes, we used all of them. So it just came out once we divided into those categories of low PD hardwood versus conifer versus high PD hardwood, that it actually separated out all of the non-high impact scolytines fell into those other categories, and that really those low PD scolytines, a higher proportion of them just are the ones causing problems. And so there was a lot of debate because are they the culprit, or is it the fungus that they carry that's the culprit? And we can't tease that apart. And so we did keep them together. So we have Scolitis multistriatus is in the same one as red bay ambrosia beetle and that cohort. They all fell into that low PD hardwood feeders.
Thank you.
Mm-hmm.
Lee?
Hi, Angela. Thanks so much for a great presentation. So I have a question about the determination of impact at the beginning. Through history, like in the last truly 100 years, sometimes we've seen invasive species that start out seeming really low impact, and then they go through some sort of an indeterminate like release or transition. And actually brown-tail moth is kind of a weird example of that, to be honest. I know you're like, don't mention brown-tail. But there's other examples of that through history where we have these non-native insects or diseases that seem to be doing kind of functionally very little in the ecological space. And then all of a sudden they become destructive. So they experience some sort of a shift. And it's not always well understood why. So the question I'm trying to present is, on that scale of impact, do you have any history of insects jumping across the scale, or any entity jumping across the scale? How are you working that into your modeling?
So we from the get-go, we said we had to follow a very strict protocol, because especially when you have experts in the room, they disagree with what other people may write, or with that one from so-and-so back in the day, they were wrong. And so we can't look at it that way. And so we developed the strict protocol where if there was any publication that said that it killed things, even if it was 60 years ago, and it doesn't do anything now, that we gave it a high impact score. Because there was, I want to say like large sawfly or some sawfly that when it first invaded was highly detrimental up in Canada. And then a biocontrol program was instated, and it actually worked really well, and it declined, and now it's no longer a pest. And so do we include it or not include it? And we said, no, include it, because when it first arrived, it was high impact. And so there is something going on there that would cause that effect. So if anything in the literature said that it was high impact, we checked it off as high impact. So brown tail moth is definitely high impact.
Right. So you went with like an inclusiveness approach. So even if it has a hint of high impactness, it counts as high impact. And that makes perfect sense, because if you use that example of whatever sawfly example, concept, it's like, yes, sometimes things have a big splash, and then through science or happenstance, they become controlled. And that doesn't mean them not high impact. That means that we had some sort of form of success, right?
Yeah.
That's awesome. Okay. Yuri has his hand up as well.
Sorry, I hope I'm not talking too much. The question of impact also brings me to the question of, in plant pathology, they have the pathology triangle, where for a disease to manifest, you have to have the pathogen, the host, and the environment that's suitable for the disease to actually occur, or for the death to occur. And in insect or forest entomology, we don't use that, and it's silly, because it's exactly the same thing, that the great majority of the bad bugs, with the exception of the few that are invasive and that really kill healthy trees, the great majority of our, let's say, the native species, or the species that are displaying big impact in their native habitat abroad, and therefore we're classifying them as big impact, it's because of tree stress. And that's going to be increasing as we're happily heading towards 4 degrees above normal in the mid-century. That is going to be, I predict, way bigger impact than the provenance of an insect, that trees are constantly under stress. Can we tease that apart in your modeling?
Unfortunately, not really. We did notice, we have another publication that we're submitting here where we just did all 500, like, what generalizations can we say about them? And what we found was that most of them do have the climate match with North America. So most of our species are from the same climate zones. But the model itself it's too hard to try and factor that level of detail into it, especially with the low sample size, like, because less than 5% are high impact. It was only 22 species total that cause high impact in North American forests. And so, yeah, it's interesting. And in case you hadn't heard, Yuri, we just caught southern pine beetle in Maine. And so
Yep.
Yeah, we're definitely seeing the effects of that change and species kind of behaving appropriately for them to it.
That's right. And what concerns me also, how we all parameterize our models, our predictions, is that the reports from overseas, we bump into that all the time, particularly looking through gray literature, like government reports, student dissertations, and such. Every scientist always says that my pest is the most important one, and they're usually saying that because of records from plantations or greenhouses or somewhere where something goes wrong. Somebody records that and says, look, it's a pest. but it's so out of balance because the 99.9% of other situations, the bug is not a pest, and we don't include that in our models. And so we tend to heavily weigh the rare occurrences of pestiferous behavior. And I feel like this is what's really a lot of false positives in the records from overseas.
Yeah, and I think when we looked at it, we were actually relieved that we had a higher chance of false positives than false negatives. Like there was no issue with false negatives, that's the scary one, saying that it doesn't have a chance of being high impact when in fact it wreaks havoc. But yes, that there will be these false positives. And it's a matter of the user basically determining where is their cutoff point to what they deem to be too risky. You know, is 1 in a 10 chance? Okay, I'm okay with that. But others might not be. And so, yeah, overly cautious.
Thanks for the question in the chat about other types of pathogens, and whether, I guess probably the best question for you, Angela, is if you know anybody else sort of working on a similar type of analysis related to those kind of risks. Since I don't think you can do it yourself, there's like probably too many things to take on.
Yeah, so basically instead of looking at insects, looking at pathogens and how they would, yeah, we've chatted about it, that we envision that there's probably going to be a very strong evolutionary history relationship again with the relatedness. And, you know, that might be part of the reason why the specialist scolytines have that linear relationship instead of the quadratic, is because of that close relatedness between the hosts that the fungi are able to utilize, the tree host. I'm just totally hypothesizing. Probably Yuri's better to answer that question. And so I hope that there are some forest pathologists out there, hint, 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 that would like to take on that lead and look at something similar, just with a different system.
Yuri, any thoughts from your end on that?
I can't remember if we discussed that with Lee or not yet, but I find the plant, like there are a lot of entomologists that like to speak on behalf of the field of pathology, and I'm not brave enough because those are such different organisms. You know, we've caught the sudden oak death pathogen in the Southeast so many times, and it never did anything. There are so many examples of how we don't quite understand the ecology of fungi. There are so many examples of when entomologists talk about fungi and bacteria as microbes, as if it was something like a group. You know, we're so sloppy in our thinking about the world of fungi. I'm not going there, not today.
I think the question that Faith poses in the Q&A box is really valid, though. This type of work can really shine a light on the you know, the high impact, low impact, unknown impact, and what factors play into that, you know, that result. And it should be extended to the pathogen and fungi and everything world, and absolutely nobody on this call appears to be qualified to do so. You know, it's critically important work, and we do see huge forest pest impacts by those groups. I mean, sudden oak death is obviously showing up in eastern waterways for at least a decade now, and yet does not seem to cause host damage behaviors yet. And I say yet because we have all sorts of factors, like I was trying to get to before, where things shift in their impact over time for causes that sometimes are never clear in history. So if we seed something accidentally, like a pathogen, into a new environment, it could take 100 years before that release occurs. I think it's, Yuri, to get back to your, you know, known knowns and known unknowns, sometimes we have these situations where, you know, we know we're putting pathogens where they haven't been before. We don't know whether or not that will become an impactful action.
I completely agree. I sort of evaded the answer so that I have more time to think, but there is plenty to say about our lack of attention to pathogens. One straightforward answer is that, you know, there are lots that we don't know. There are lots of species we don't know. There are lots of their interactions with American flora that we don't know. But there's also quite a few that we already know are dangerous. There are you know, lists out there. The APHIS maintains a list like that. So we don't have to know them all. We just have to start truly focusing on the stuff that we already know is dangerous. And what I mentioned before when Angela and I were talking about the influence of the environment, this is probably even more important in terms of pathogens, because, you know, the most important thing in the life of a fungus is water availability. And little changes in humidity, in the air and such can make a huge difference between a pathogen or non-pathogen, probably more than in bugs. The little differences in temperature mean a huge differences in the fungus ability to survive, thrive, sporulate, that kind of thing. Again, I don't want to speculate too much on the ecology of fungi. I just wanted to say, let's not talk about trees and pests or trees and pathogens. Let's talk about trees, pathogens, and the environment together. Without that, we're missing a massive, big piece of the whole picture.
Yeah, am I on now? Okay. Yeah, I was thinking of the pathogens more that are not insect vectored, which was where we were earlier. But in any case, 15 of them are having huge impacts in North America, some of them huge impacts in other parts of the globe. There are hundreds out there that nobody knows anything about, but as Yuri said, we know about 20 of them anyway that are serious. And it's interesting that the Europeans are putting a lot of energy in Phytophthora, but I don't see the same in America. And we're going to be up the creek if some forest pathologists don't do it. And in the past, at least, APHIS hasn't been interested in paying attention to what the Europeans do. So we're really going to be up the creek. And yeah, maybe there's nobody on this call that's in a position to do much about it, except maybe you, Lee, and pushing through the Nature Conservancy and the dialogue to get some more serious attention to trying to determine which of the 200 known species of Phytophthora, for example, are likely to be a real problem when they get to this US. And then there are other genera that we should be looking at also, but it's easier to deal with insects. We have a much bigger database. We know much more about them. And since its beginning, APHIS and the rest of the forest community have paid more attention to insects than the pathogens, maybe just because they can see them, and catch them and whatever. But those pathogens are really damaging, and ignoring them is not helping us.
Yeah, I agree entirely that, you know, we have to make sure that we give the pathogens their due, and they are sometimes a lot more challenging just to understand the systems, you know, just like we were talking about. They show up in places and seemingly have no impact, and that's really difficult as human beings to deal with in the system. So I did just make a note for our strategic planning process, which is, you know, one of the reasons we're having this webinar, to highlight these moments where we identify, oh, this is a perhaps a blind spot, or at least we're perceiving it as a blind spot. Perhaps it's not one, and we'll determine that that later in the process. But this might be a place where we can put some energy in the coming year, or I think it's 1 to 5 is what we estimated, for better surveillance, for better you know, mutual information exchange, for instance, all of those things, because the Phytophthora are a great example of a really worrisome group of organisms.
Well, and analysis, getting with the Europeans, working with the Europeans, taking what they've done and
Yeah, absolutely.
twisting it to the North American situation, whether it's different species or some question that the Europeans haven't gotten to yet or whatever.
Absolutely.
But there's hardly, well, anyway, you heard me.
I appreciate it. Yeah, and I think one of the things that you know, we need to consider too is do we need, there's not a very clean way to say this, but do we need at its core more information to do the preventative work that needs to be done? So do we have to know which Phytophthora, for instance, are the most hazardous in order to prevent all the Phytophthora? Do we need that information or not? And that's the type of thing that we need to really consider in the strategic planning as well. Is the need more research, or is the need more active policy changes to prevent the entrance of any pathogen, regardless of its potential impact?
I go for column B. I go for column B, but can you persuade the phytosanitary powers that be to do that?
That's right. And so that there's a interplay between the two. Yeah, absolutely. Well, thank you, Faith. And this proves we can take people off mute if they ask. So thank you. If anybody else wants to speak up with a question instead of typing it, please just let us know and we'll do it.
Or if you are a subject matter expert related to the ongoing conversation and would like to chime in, raise your hand and we can take you off mute.
There you go.
And you don't have to jump on with your camera. I think this might have been answered, Angela, earlier, but Warren Remy put in a question asking about whether temperature was a consideration in the analysis.
Not in the analysis directly. We're kind of making the assumption that the insect has already arrived, had the climate match, has established, and kind of what would its impacts be. So we're not making any judgment or assessments about its ability to invade. We're kind of the after that would happen point. What are the risks?
And Gary makes the point that facilitation of trades makes all of this much more difficult, which is very true and part of what we'll be talking about tomorrow. One other thing that struck me as you guys were talking about temperature and humidity is that one of the issues related to biodiversity loss is desiccation poses a greater risk to insects than almost any other species in terms of loss and vulnerability. And I was just thinking about the balance in terms of at-risk trees that are under stress in the West compared to potentially the impact on invasives there. And I'm assuming people are looking at that, but I was trying to think, is there any way that that could be like a biocontrol in its own right? Probably not, but but could it help reduce potentially the likelihood of, you know, an expansion and establishment of populations out there? I'm just sort of thinking aloud. Gary also asked, where did spotted lanternfly land in the model, or did you look at it as a forest pest?
Hi, Gary. No, at that point, we determined that it hasn't been here long enough to actually know what its full-fledged impact is going to be. And so we couldn't make a good enough assessment about that because there's still debate about kind of the level of impact it's going to reach. So we did not include spotted lanternfly.
I think Faith has another question. Laurel, can you unmute her?
Too many buttons to push. On the issue of desiccation, Aaron, certainly changes in moisture patterns, rainfall, droughts, et cetera, are going to rearrange where everything finds a suitable habitat. Parts of California may no longer be suitable for sudden oak death if they dry out enough. They might also not be suitable. It might not be suitable for any of the trees that sudden oak death lives on, but that's another problem. But I don't know. I guess I resist this idea that droughts and climate change are inevitably going to increase the numbers of invasive species. I think it's going to change where they go and where they find suitable habitats. And it will make it, I suppose, more larger parts of the country will be suitable for the tropical ones that Yurgi is looking at. But it's a simple statement that isn't. I don't think it's well founded, but that's my bias.
Yeah, I think one of the other challenges is to, as things change, how do populations move even from one part of the country to another where they might have better chance of becoming established where previously they wouldn't have thrived. And you know, Faith, we've had plenty of conversations about APHIS and their priorities and them not having enough resources to try to track what's happening here already. But that's still something on our priority list. Yuri, let me turn it over to you.
Yeah, Erin, I wanted to react to what you said. Faith sort of did that, but I just wanted to comment on the lab that we have in the Western forests. You know, what happens when you combine the real impacts of the climate change and local bugs and some imported bugs or pathogens. And what we are seeing is, it suggests to me that, I mean, this may sound crazy, but I almost feel like by calling the emerald ash borer and the Dendroctonus beetles the same name, pests, prevents us from seeing that they're dramatically different in how they work. The emerald ash borer is an invasive pest that chews up living healthy trees. The Dendroctonus beetles are completely and 100% dependent on people mismanaging the landscape. They are sort of a symptom of either we are heating up the planet, or we are preventing wildfire, regular fire ecology, or we are overstocking the forest, or we are sort of doing or imagining the trees and the woods different than they would be in their native ecology. It's a part of an ecosystem, inevitable part, indispensable part, and yet we are lumping them in the same category. And I think that's unfortunate, because in the case of most of the Western beetles, they're a symptom of what's happening. They're not the cause. And because we're so focused on those beetles, we're not actually able to communicate to people outside of our community that the beetle is not the problem. We're not going to get rid of the beetle, one. Second, it's not the cause of the problem. It's really the stuff we're messing with the environment. So again, communication issue. But then, Erin, you also mentioned something interesting about a coordination with, I may have misheard, but so correct me if I did, but something about other countries and export of pests and pathogens and that kind of thing. I can't exactly remember what you said, but what did come to my mind is the impeding catastrophe that's called laurel wilt in Central and South America, that I'm not seeing anyone modeling, doing anything about, being concerned about. You know, we talk about the US and Mexico and Canada, but Mexico is part of North America. It's our major importer of fruits, of all that stuff, you know, the kingdom of avocado, and the kingdom of also the hotspot of pine trees, the biodiversity hotspot. And it's, you know, from Mexico south, the laurels have really diversified. There's lots of species of laurel trees, and we don't even know how many of them are susceptible to laurel wilt. It's going to be a hot mess. The moment the beetle jumps from Texas to Mexico, just watch what's going to happen. Everyone's going to be busy monitoring. It's going to be too late. So just bringing it out there that we are also exporting stuff to other places.
Yes, we are. And Yuri, I think you get to a really good point where when we have an uncontrolled spread situation, which is essentially where we're at with laurel wilt, you know, we serve as the infestation point for either contiguous or non-contiguous other countries. You know, so for instance, our cactus moth situation is going to be a complete tragedy of the cactus family once it reaches the Mexican strongholds of pad cactus. You know, that's not a tree unless you're a tortoise, in which case it might as well be one. The notion that we sometimes struggle, well, the notion that we should sort of disavow is that the United States is somehow special. We are not in the least bit special. We export plenty of worrisome forest pests to other countries and islands. some of which are native, and then other of which are just so thoroughly infesting the United States that we form what is sometimes called the beachhead contamination. So for instance, brown marmorated stink bug is a huge issue of export, and that is not native to North America. So not only do we get this problem where we're killing our own, biodiversity and our carbon sequestration potential and everything, but we're also imperiling other nations, whether contiguous or not. And that's, it's just bad citizenship on the global stage of forestry, which is disappointing. And the more we control the pests that enter us as a major trading partner with so many countries, the better we do on the global stage in terms of not destroying global biodiversity. And, brown marmorated stink bug does not have a carbon sequestration impact to the best of my knowledge. So I sort of conflated two things, but it has huge agricultural impacts. And that's why Australia is really concerned about us accidentally exporting that. And a gentleman named Warren says that yes, so when you move timber across the United States, you can often find that there's a lot of insects born in that, just with interstate trade, which is absolutely a phenomenon that we all are familiar with. So thank you for bringing that up. Yuri, what's up?
I again hope I don't talk too much, but what you said also brought me another thought, which is that we are not only exporting goods, sometimes infested, but we're also exporting a lot of literature and science and knowledge and management ideas, because science, forest health protection, that kind of thing really works here. It's a very active field. It's much less active in many other places in the world. And so a lot of folks that I deal with elsewhere in the world are actually sort of consciously or subconsciously adopting the kind of science that gets produced here. And I don't know if it makes sense to talk about it here or not, but I often find out that it's incorrectly applied, or that like we're publishing stuff that really is applied here, but we're talking about it as if it was a universal thing. And I often bump into it we talked about Mexico already, or Central America. I find out often that people there are managing woods, particularly their pine forests, with the same assumptions and tools that have been used in the US. But it's incorrect. It's the same, like we talked about these beetles being pests. It's the same sort of mentality, because we are doing all this research. Folks there are often reading that same literature, and instead of managing their trees and forests according to the indigenous ecology, they're just adopting our stuff. And so again, communication thing that we don't even know that often, but what we communicate to the rest of the world, you have to be careful about as well.
Does anyone else from the audience have any other questions or comments or thoughts or ideas you want to share? Or Lee, any other questions to the audience that would be helpful to solicit feedback on?
Yeah, I might. Faith said she had a question regarding Mexico, so let's just take care of that, and then I have one more question for the group before perhaps we'll wrap it up. Faith, can you take yourself off mute? I'm not sure.
Yeah, not quite a question with regard to Mexico. I can't type on these machines. In the case of the Lauraceae, laurel wilt, I hope it doesn't turn out to be like with the cactus moth. Mexico was very excited about the cactus moth for a while, managed to eradicate a direct infestation into the Yucatan Peninsula, and then decided it had bigger fish to fry with the US and quit complaining to the US and quit pushing APHIS to do something. APHIS did a fair amount on cactus moth with no support from inside the country for about a decade. With Lauraceae, I don't know if they're paying attention, and it is awkward, difficult. I don't disagree with you, Jerzy, that we should be doing a lot more about it, but if the Central American countries aren't jumping up and down, it's easier for USDA and others to ignore it. And it's a very difficult animal to deal with, as you know. I mean, all it takes is one dang beetle. And so it's not going to be easy, but it is a disaster. It's a disaster here. It's going to be worse probably in Central America. And too many people are whistling on by and not paying any attention.
Yeah, the laurel wilts is an excellent example of a very high impact pest that we have virtually no tools to deal with. It would have been far better to prevent it from entering in the first place. Which is why we're having this sort of before the border conversation is, we didn't know it existed ahead of time. We didn't really recognize it was here for arguably too long. And we still haven't developed any good tools to deal with it. It would have been a lot better to have a system in place that never allowed it to get to Savannah, if I'm not mistaken, in the first place. And so getting to that prevention level before the border, before it hits our ports, is a huge area of focus, because it's so much more effective for these situations like laurel wilt, where, we never should have gotten to the conversation about how to keep it out of Mexico in the first place, because we should have kept it out of North America as an entire continent. And we don't really have good tools on that pest and many pests like it. So I guess the conversation has been very enlightening. I've taken a bunch of notes, and I know Erin has as well. So if anybody has any sort of closing thoughts on where they would like the Nature Conservancy, the Continental Dialogue, or the Grand Challenges in Entomology to focus in the future, that you haven't expressed yet, you can either email me or Erin. You can tell us right now, you can put them in the chat. This is your moment to speak up. But other than that, once everybody's spoken their piece, we're gonna probably close up the discussion for today and then join back up tomorrow at 2 p.m. Eastern. So if anybody has something to offer. Oh, thank you. Erin put her email in, and mine is also, I'll put mine in again just for convenience. All right, so we have a suggestion about improving our insect pathogen commensal knowledge. Those are tricky ecological relationships, so I will put that in.
While Lee is jotting that down, I just wanted to take a moment to thank everybody that joined us today. I know it was short notice, and we really appreciated everybody coming together. Yuri, I realize you have your hand raised. I'm really bad at this. I apologize.
No. I talk too much anyway. I just was gonna say one last thing. Thank you so much for everyone who organized this and who listened. I think we have one major advantage in what's happening right now around the world, which is that we have a pretty good pandemic happening on people, and we should, as a community, absolutely take advantage of that and sort of beat it over the head of people. And it's interesting that folks are often saying, like, use that as an example of when the proverbial shit hits the fan, we as a humanity can sort of get together and, develop vaccine within like a year and a half, and, vaccinate 500 million people. Great. But then you hear that, some trees don't really matter that much as people. I think it's also an opportunity for us to say that, the climate change is a bigger problem than COVID. And this is what it's about. It's really about global change, and we're, messing up our ecosystem and the atmosphere. So this is actually sort of, in terms of communication, it's not a bad time for us.
Well said. So Angela, do you want to offer any concluding thoughts?
I feel like there's been so many great conversations that have stemmed off of our talks. It's just really exciting to be a part of the conversation and to see the motivation to keep pushing it forward and to keep asking these questions and to keep looking at ways. And, the changes that are occurring, I'm a little scared up here in Maine with everything that's coming this direction. Didn't quite grasp what I was going to be dealing with when I said yes to this position. But yeah, there are a lot of changes on the front. Some of them we may have the power to do something about, others we're not going to, and hopefully we can get more folks on board with the stuff that we can influence. So, thank you.
Well, I think we'll wrap up, but I will leave you all with the reminder that we have talks tomorrow as well as next week. Take a look. The Entomological Society webpage has them in the calendar format, so they're real easy to find by date. You can also go to the Continental Dialogue website and look at the 2021 virtual webinar. It's the same links, so whichever is more convenient for you. And Erin, do you have any closing words before we end the recording and say goodbye to everybody?
Yeah, this is, I think, a great series of presentations. I learned a lot in the process, so I appreciate it. I have several pages of notes. And I also appreciate conversations that are accessible enough to a non-subject matter expert that I actually could understand what you guys were talking about. So I really appreciate the opportunity to hear from you and for you making time to chat with us. And we look forward to working with you further, since I will be continuing to enlist both of you. Thank you.
Thank you.
And thank you, Giovanna and Laurel, for your assistance on the back end as well. All right, well, with that, Lee, I think we'll wrap it up and we'll hopefully see a bunch of you tomorrow. And thank you again.
See you tomorrow.
Stay safe. Bye, everyone.